we have actually derived the equation for the zero input response, and then also for the impulse response. That was the second part of the second step for it. And the third step we are going to do is we are going to find out the zero state response. Okay, now let's look at that. Zero state response. Let's name this one as set S that represents zero state. That is equivalent to f of t convoluted with h of t. F of t is equivalent to u of t is given in the question. So I'm gonna do that here, substitute that right here, substitute that one here for the f of t, u of t, and then h of t is the one we found out from the last video. That is 2 minus e power negative t times u of t, and if you expand this one, this is going to be 2 u of t minus e power negative t u of t. Okay, so here if we expand this one furthermore, this is going to be u of t convoluted with 2 u of t minus u of t convoluted with e power minus t u of t. Here what we are going to do is we are going to do this as a two separate thing, like we are going to find out the expression for this one and also for this part right here, and then we are going to combine them together. So first let's deal with this one, u of t convoluted with 2 u of t. U of t convoluted with 2 u of t. If I give the integration expression for this one, this was negative infinity to infinity, u of tau, 2 u of t minus tau d tau. And if I draw the graph for this one, u of t is, the graph for the u of t just look like this, and 2 u of t minus tau, this is a time reversed, so it's going to go to the opposite side, but it's also 2 times higher than this, so the height is going to be at 2 right here, and it goes to the opposite direction. So this is how it's going to look like. And this is tau, this is 0, this is t. And if I write this one in terms of piecewise function, this is going to be 0 when the time is less than 0, and 2t when the time is greater than or equal to 0. Okay, so from this one we can say this is 2t u of t, the final expression. So this is for the first part. Now let's look at the second part. Second part is u of t convoluted with e power negative t u of t, u of t convoluted with e power negative t u of t. If I express this one using integration, this one an integration negative infinity to infinity e power negative tau u of tau u of t minus tau d tau. If you look at the graph for this one, here we are going to have a unit step function, but that is when it's time reversed, and also we have exponential function that is negative exponential, so the graph is going to go like this, and the unit step function is time reversed, so it's going to go to the opposite direction. It's gonna go like this. Okay, so let's find the expression for this one. If I express this one in terms of piecewise function, this is 0 when the time is less than 0. And it is 1 minus okay, once again. So first we have to, so we know that this is 0 when the time is less than 0. It is 0 when time is less than 0. And to find out what happens when it equal or greater than t, we can put it in the, we can solve for this integration, that is 0 to t 1 times e power negative tau d tau. Therefore negative, if you do the integration, that is negative e power negative tau going from 0 to t, that is equal to 1 minus e power negative t. So this is 1 minus e power negative t when the t is greater than or equal to 0. So we can also conclude this one as 1 minus e power negative t times u of t, because u of t only activated after 0 equal to 0. So this is equivalent to multiplying this quantity, like this is equal to the total thing, because when t is less than 0, that is 0, and when t is equal to or greater than t, that is this one. So that is the unit step function. When you multiply by the unit step function, this is going to give you this whole thing. So finally we can express this zero state response as this: y zero state is equal to z c. Okay, 1 second. This is c t u of t minus 1 minus e power negative t u of t. And if we simplify this one, it's 2t. Okay, 2t u of t minus 1 minus e power minus t u of t. And if I simplify this one, this is 2t minus 1 plus e power negative t u of t. U of t. So that's the zero state response. Now if I want to write total response, I have to combine the first video. In the first video we derived this one, 2 minus e power negative t u of t, 2 minus e power minus t u of t. But in this one, second one, we derived this one, 2t minus 1 plus e power negative t u of t. So the total response is going to be addition of both of them. For total response, that is equal to y of t is equal to y0 of t plus y0 state of t. y0 of t is the first one we found out, that is 2 minus e power negative t u of t. And the next one, zero state response, we just found out that is 2t minus 1 plus e power minus t u of t. And we can simplify this one, and if you simplify this, gonna look, the expression look like this: 1 plus 2t u of t. And that's it. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel.